Good morning, good afternoon mostly, and good evening to some of you, ladies and gentlemen, excellencies and others. My name's Vincent Johnson, and I'm moderating this third online training webinar presented by the International Coconut Community for the Non-Aligned Movement Centre for South-South Technical Cooperation. Previously in September and October, we had webinars on nata de coco and marketing and processing of coconut sugar. Today's subject is good agricultural practices, replanting programs, and integrated pest management to sustain coconut development. We have 4 speakers today, so I'm going to encourage everybody to keep to time. Please, if you have questions, type them into the chat. And we will address them in the discussion section at the end of the webinar, not during the speakers sections. Just a couple of ground rules. If you have mobile phones, turn them off or put them on silent. Please also bear in mind that all the information available will be provided through this social media. I'm just going to share my screen. You will be able to access all future programs through these different social media channels from the International Coconut Community and the Non-Aligned Movement Centre for South-South Technical Cooperation. Mridula, is that visible to everybody? Mridula?
Yes.
Is the slide visible to everybody?
No, share
Just
screen.
a moment. Let me press share. Do beg your pardon. Can everybody see that now?
Now we can see.
Yes?
Yes.
Okay, so
Yes.
yes, fine. I think the important thing for this program is we have four speakers with 15 minutes each. Please try and keep to time and avoid lengthy descriptions or overuse of acronyms. We know all of that. So without further ado, may I invite the Executive Director of the International Coconut Community to provide opening remarks. Over to Dr. Jalfina Alao. Thank you.
Thank you, Vincent. Good morning, good afternoon, and good evening to all. His Excellency Ambassador Dr. Nurbintoro, the Acting Director of NAM Center, Honorable NLO for ICC, representative from the ICC and NAM Center member countries, distinguished invited resource speakers. We have here Dr. Ponciano Batugal, the chairman of the ICC Technical Working Group, Dr. Subramanian from CPCRI India, Dr. Nayani from CRI Sri Lanka, Professor Jimmy Botella from the University of Queensland, Australia. Distinguished scientists, farmers, coconut industry, ladies and gentlemen. I have the pleasure to welcome you all to the third online training program organized by ICC and NAM Center on good agricultural practices, replanting program, and integrated pest management to sustain coconut development. And this is part of the online training and webinar series under the theme Stay Healthy and Productive during COVID-19 pandemic. Ladies and gentlemen, coconut has contributed directly to the amenity and income for more than 20 million smallholder farmers and their dependents, providing food, health benefits, shelter, structural products, and aesthetic beauty to the landscape. The global market's impact in importing countries would involve consumers numbering up to nearly 500 million households utilizing fresh coconut-based food and functional food, byproducts, and non-based food. So the overall impacted population fully engaged in the coconut value chains, it is estimated at 700 million people. So domestic and global demand for coconut-based products, as you may know, has continued to increase. So it is expected that the demand of this product grows at a CAGR of over 26% during the period 2019 to 2025. And it is driven by the growing preference for beverages which are naturally healthy and convenient, to name a few. However, the production of coconut hasn't significantly increased in response to the growing demand. Most of today's coconut palms were planted like 60 years ago or even more, where production tends to decrease and the fruits are more challenging to harvest. A comprehensive program is needed to prevent the downward trend of coconut supply to save the coconut industries and the producers. So, ladies and gentlemen, replanting is not as simple as planting more coconut, but smallholder farmers would need technical and perhaps financial assistance. So yield losses caused by pests and diseases also are reported from most of coconut producing countries. So we need accurate and straightforward tools for pest and disease identification. And through integrated pest management, we hope to effectively and efficiently manage the pest and disease populations, optimize the agricultural productivity, improve farmers' welfare, and guarantee environmental protection. So today we have 4 experienced speakers for the training. Some of them will share technologies that have been practiced in their countries. So I believe many countries have developed their innovative technologies also, which we hope can be harmonized as an international standard. So together, let's accelerate the exchange of ideas, technologies, and scaling up of good and acceptable practices. I'm confident that you will find new ideas and novel partnerships through this event to sustain your effort in support of sustainable coconut development in your country. Lastly, I wish you all a very successful online training. Thank you. Over to you.
Thank you very much, Delphina. Before we move on to our first speaker, I do want to announce that we are going to encourage all of the delegates, of whom there are now 132 at least online, to fill out the evaluation form at the end of this webinar. If you do that promptly, and once we receive the form, you'll get your attendance certificate. So thank you very much for that. Also, I would like to point out that the 4th and final webinar of this series, we're provisionally projecting to have that around the 8th of December on COVID-19 and health, because by then we hope to have the important results back from some clinical trials. So without further ado, I would like to hand over to Dr. Ponciano Batugal, who's going to talk to us about sustainable coconut development for a better future. Dr. Batugal is the currently the chair of the technical working group for the international coconut community, and as most of you will know, also runs his own charitable foundation. Thank you very much, Dr. Pons. Over to you. And I'll give you, yeah, fine.
Good morning, good afternoon, and good evening to everyone. Honorable Ambassador, Dr. Jelfina Halu, and participants of this training course. The topic assigned to me is challenges and opportunities for the coconut industry for a happier future. I'm presenting on behalf of the Technical Working Group of the ICC and on behalf of the Farmers Community Development Foundation International, where I serve as President and Board Chair. I included here my email address, just in case some of you might want to communicate for clarification or other questions related to my presentation. My presentation has three topics, the challenges, the opportunities, and the way forward. How do we address them? The present situation is characterized with the following. The coconut farmers, 92% of them are smallholders, tending 1 to 2 hectares each. They earn about $400 per hectare per year from copra, a product in which the price is low and unstable. In many cases, they do not own the land they till. They are not bankable by the formal banking sector because they don't have much income. They have inadequate access to technology, capital, and market. They have low farm productivity and profitability, and they are marginalized, most of them living below the poverty line. As most of you would recognize, coconut farmers are the foundation of the coconut industry. Without coconut farmers, we don't have a coconut industry. And as of now, the coconut farmer is not earning enough from coconuts, which I will discuss more later. And our survey indicates that if he doesn't earn more, he will not plant more coconut. The situation in the processing industry is as follows. Raw materials are lacking now, more so in the next 5 to 10 years. Many factories, even in the major coconut producing countries, are operating below capacity. Senile palms need to be replanted urgently so that there will be enough raw material to process. And also there is the negative campaign against coconut oil. So these constraints need to be urgently addressed, otherwise we may lose the coconut industry in favor of other short maturing vegetable oil crops. But luckily, the coconut oil has a premium quality that cannot be matched by the other vegetable oils. This is the world coconut situation. The market is rapidly expanding, especially for high-value coconut products, in fact, exponentially. But the production is going down, and a major cause of this is the senility, the aging of coconut trees with declining yields. This is the desirable situation, according to Dr. Oropesa, where the market expansion is matched by the production. We can do this by large-scale replanting of early-bearing, high-yielding, and disease-resistant varieties, hectareage expansion over and above the 12 million hectares that we have now, and the use of innovative technologies that are science-based, doable, affordable, and sustainable. What are the challenges confronting the coconut industry? There's a global decline in coconut productivity because of palm senility, typhoons, pests and diseases, drought, lack of quality planting materials, and equally important, coconut farmers lack resources to improve their farms. Example of aging senile palms, many of them are over 60 years old. In the Pacific region, some countries have over 70% senile palm. Palms are also too tall to harvest, and in this picture, they are too close to produce good yields, and very little effort to replenish plantings. A major constraint would be the lack of adequate supply of good quality planting materials. Typhoons. In 2013, Typhoon Haiyan felled 33 million coconut trees in one day in the Philippines. And this typhoon, the strong winds are experienced also in other countries like in the Pacific, in the Latin American, Caribbean, which are disincentives to coconut production. Pests and diseases, the little yellowing disease, which is a dreaded disease in Africa, the Latin American, the Caribbean countries. The rhinoceros beetle, a strain, is now found in the Pacific. Palm weevil in many countries, mites, pests affecting coconuts, root wilt in India, Weligama disease in Sri Lanka, Ogia disease in Papua New Guinea, and kadang-kadang in the Philippines. These are diseases that need to be addressed through research for development. Coconuts are grown in rain-fed areas mostly, and they suffer during the dry season. So there's a need to develop innovative system of water harvesting so that we harvest the water during the rainy months, store them in earthen pans, and use them for irrigation during the dry season. A lack of quality planting material. We don't only need varieties and hybrids that are high yielding, but we need to produce good quality planting materials so that they will develop into robust and high yielding palms. Why are coconut farmers not earning enough? Mainly because they mainly produce and sell copra, where the price is low and stable. The coconut hectareage is small, and many or the majority of them plant coconut as a monocrop. Their earnings is very low. They are considered non-bankable. They don't have enough resources. And equally important, in many countries, they cannot influence public or private sector policy. What are the opportunities? There are three that I have identified. The opportunities are the rapidly increasing demand for high-value coconut products, the innovative technologies that are now available for increasing yields, the capacity building and technology transfer activities that are being promoted by ICC and other institutions. The rapidly increasing demand for coconut is evidenced by the increase in the use in the vegan and ethnic foods, because coconut is generally regarded as safe, or a grass food, they call. It is used in the nutraceutical, oleochemical, cosmeceutical, pharmaceutical, health and wellness, environmental services, and lately in the biofuel industries. There's a comeback, we call, from a sunset industry before the 1990s to a sunrise industry. In 1993, there were only 29 high-value products. But in 2017, there were now 96 coconut high-value products, and this number is increased 50 to 100 every year. These are examples of the products that can be produced from coconut, both by the commercial sector and smallholder farmers through SMEs, the small, medium enterprises. A coconut shell for fashion accessories, coconut shell for decor and souvenirs, coconut water, coconut sap sugar, which is good for diabetics because it has a low glycemic index, a coconut sap drink, which is very popular in India, the coconut sauce, which is a good complement or replacement of soy sauce, And lately, the new product called medium chain triglyceride, or MCT, from virgin coconut oil. It is an energy booster and memory enhancer. And this is a very attractive product in the market. Coconut chips for snacks. And the second opportunity are the innovative technologies for increasing yields. Our traditional varieties normally produce about 50 nuts per tree per year. The third column is missing. But if you use hybrids, you increase the yield by 3 times. If you use hybrids plus modern technologies, you increase the yield by 5 to 6 times. So the question is, what are we waiting for? The third opportunity is capacity building and technology transfer. There are international training courses for the development officer, and one is being offered by the ICC in collaboration with the Sri Lankan Coconut Research Institute. This is offered every year with 20 batches every 1 to 2 batches of 20 participants every batch. We have the COCOTEC, or the biennial technical meeting of coconut experts and industry experts, where people meet to exchange ideas on how we can improve the coconut industry. The ICC has publication, videos, seminar presentations such as this one. And we have technical research networks where researchers and development workers can interact, such as the Coconut Tissue Culture Network, Integrated Pest Management Network, Coconut Oil Forum, and the Genetic Resources Conservation and Use Network, or COGEN, with 39 member countries. So how do we address these opportunities and challenges? There are 2 suggestions I have. One is the ICC collaboration with the coconut alliances and coalitions of coconut producing countries. Currently, we have collaboration with Colombia, with the South Pacific Commission with its 22 member countries, with the ITC Organized Caribbean Coconut Coalition with its 11 member countries, and we're proposing a collaboration with the Coconut Coalition for the Americas, which are the processors and traders of coconut in North America, and a coalition for Central and South America, and one for Africa. The second way forward is the technical assistance that ICC can provide to priority projects. There are several here, but in the interest of time, I'll zero in and focus on the coconut farmers. What projects can we help to help coconut countries improve the lot of the coconut farmers? We could help them through poverty reduction in coconut growing communities projects. I invite the participants to view a 10-minute video from YouTube. It's titled Coconut Farmers Need Not Be Poor. This will give you an example of a poverty reduction in coconut growing communities. Piloting of food and income generating systems to protect coconut farmers because of the COVID-19, to protect them during and beyond the pandemic. The production of organically grown coconut to arrest yield decline and benefit farmers with premium price of organic coconut. As you know, many farmers grow organic coconut, but this is by default because they cannot afford to buy expensive chemical fertilizers. This technology will help them arrest the yield decline because the coconut consumes a lot of nutrients from the soil, and if these are not replaced, the yields will decline. The production of high-value coconut products at the village level. The problem is a lot of our farmers only obtain income from on-farm activities. There are now initiatives. The Philippines has this Coconut Hemp project where they encourage high-value coconut production at the village level. So that is small farmers.
2 minutes, Bons. 2 minutes left.
Okay. The other priority projects that the countries would like to partner with ICC. So the ICC can offer capacity building, the technical expert meeting or COCOTEC, policy formulation through membership in the ICC, provision of market and production information, coconut industry status assessment, webinars, and proposals, formulation, and piloting of projects. So in conclusion, the above-mentioned challenges and opportunities are highlighted and shared through this training module. It is imperative that these challenges and opportunities are urgently and proactively addressed. This will result in a progressive, inclusive, and sustainable coconut industry. I'd like to thank you for listening.
Pons, thank you very much for that very interesting overview of sustainable coconut development for a better future. There's lots of useful information in there. The next speaker is Dr. Subramanian, who's the principal scientist at the Central Plantation Crops Research Institute in India. He's going to talk to us about good agricultural practices to sustain coconut development. Before I invite him to start his presentation, I would like to remind everybody that if you have questions, please type them into the chat and we will deal with them during the discussion element of this webinar at the end. We have two more speakers after Dr. Subramanian before the discussion. So may I now hand over to Dr. Subramanian for his second presentation. Thank you. You need to maximize your presentation on the screen, Dr. Subramanian. And then, of course, unmute yourself. We're all still learning about using these different platforms and tools for virtual conferencing. So
you can unmute Dr. Subramanian. You can unmute.
Yes, there we are, yes.
So, am I audible?
Yes, we cannot yet see your presentation, so you need to double click on your presentation, GAP, whatever, you need to double click on that on your file screen. To open it, you need to open the presentation.
Sir, am I audible?
No, we cannot.
We are audible, but your presentation is not yet open. You can open it.
Stops. 1 minute.
It's okay.
Yeah, one minute.
Yeah, it's starting to share. There we are. And now if you could maximize your screen and go to the slideshow version, please. That's it. Thank you. Over to you.
Yeah. So happy day to everyone. Honorable Ambassador, Executive Director APCC, respectable Portugal, and most esteemed Vincent Johnson, and my dear participants. So it is good to start with the good agricultural practices for sustaining the coconut development. So good agricultural practices are a set of principles, regulation, and technical recommendations applicable to production, processing, and food transport, addressing human health care, environment protection, and improvement of worker condition and their families. Coconut is highly amenable for good agriculture practices, and it is most important also. Why means, since it's a perennial crop, so that means once it started in the field, it may be there more than 60 years. So sustainability and good agriculture practices are both together. So it is utmost important that we have to follow good agriculture practices for sustainable coconut production, to conserve natural resources, and most importantly, all the technologies what we are going to use integrate effectively so that we can get synergistic effect. And most importantly, we have to reduce the occupational hazard, and finally, One Health approach to leading the sustainable production. So my presentation includes starting from ideal site selection, planting materials, planting and aftercare, water management, and up to processing. The first and foremost, the well beginning means almost 50% is over. So first of all, we have to be very careful about ideal site selection. The area should have at least minimum 150 to 230 centimeter rainfall. That means 200 and 300 millimeter. Suppose if you are not able to receive that particular area, as earlier mentioned, if it is arid or semi-arid area, then irrigation is must. But our main idea is that to harvest solar energy. So naturally, the sunlight should have bright sunshine hours throughout the year, at least per month 210 bright sunshine hours, and relative humidity is more important. More than 60% is more important than the ideal temperatures. We can say that ideal is 27 degrees Celsius plus or minus 5, and we have to take care about less than 10 degrees Celsius and more than 45. It is always not unsuitable. And when we are seeing that the mean sea level from the coconut is ideal enjoying the coastal climate, but when it is going to interior area up to 600 meter mean sea level, it performs well. So that's when we are going for commercial cultivation, we have to restrict up to 600 meter mean sea level. So it is coming in the equatorial level, but if we are going for commercial level, we have to confine to only 600 meter. Though coconut is coming up very well under wider variety, the ideal pH is 6 to 7.5. The most important is when everybody is talking about irrigation water, at the same time we have to bother about the aeration. So aeration and water, it's the coin of the same side, so that we have to be very careful about the well-drained soil also, and as a depth at least should have a 1.5 to 2 meters. Since the coconut is it's an adventitious root system, it cannot go vertically, it will prefer horizontally, so that the depth is more important. Then according to the varieties, that is varieties suitable for the different condition, most probably it can able to have wider applicability and withstand biotic and abiotic stress. And most importantly, the coming days, water deficit is the major problem, so that we have to go for varieties performing better under water deficit condition. And naturally, when we are going for the fluctuation in the market, the product diversity is more important. So accordingly, the variety, what purpose we are going, that's also we have to see. And when we are going high input, naturally, high hybrids you have to go for, and in addition, location specific varieties and the varieties which performing high biomass potential, we have to select. The foundation, even waiting for 1 or 2 years, it is not at all a problem, but we have to, because we are going to, the plant will be there 60 to 80 years. So that always go for good quality seedling. A 1-year-old seedling is ideal, which is having 5 to 6 leaves, and it should be early splitting is a very good indicator, and a higher collar girth of at least 10 centimeter with a short petiole and profuse roots. The more advantage is preferably wherever possible, we can go for polybic seedlings. There it is possible, we can go for fortified with the bioinoculant. The experiment is already proved that when we are fortified with bioinoculant, the performance is spectacular. But the question is that the transplanting shock. And another thing, major advantage of a polybag seedling is that it will come early bearing, at least 1 year early. So possible, maximum possible, you have to go for polybag seedling. The next one is land preparation and planting. Here also, depending upon the situation, if we are going by the high commercial, very big level, means it is better to remove existing plantation and start a fresh one. In the case of small holding farmers, that the farmers also, it is always advisable to go for a fresh planting. If it is not possible, they can go for underplanting, gradually removing the trees. But always it is go for fresh planting, because even the juvenile period, we can go for multiple crops of intercrops, so that till the bearing, we can able to overcome the income problem. And the ideal spacing, actually, since it is a perennial, spacing is, we have to always go for square system of planting, and a minimum 8 meter. So that the dwarf varieties, we can go a little bit lesser, but it is always advisable 8 meter and more. The reason is that coconut leaf itself is more than 4 meter length. But it is go for always a intercropping system. But suppose in a commercial way, somebody is interested going for monocropping, in order to accommodate more number of plants, they can go for triangular planting. And In fact, what will happen? Better is always go for wider spacing. If you are going for some farmers or some commercial plantation, if they are interested, perennial crops, fruit crops simultaneously from the day one, means then there is no way they have to go for wider spacing, so that they can have multi-storied cropping, high density, and of late, as an earlier presentation, typhoon, cyclone. In that area also, wider spacing is recommended, so that the wider space dissipate the wind velocity. So spacing is most important. Then pit size, this is also very, very important. The pit size will be different and the method also different depending upon the condition. If the soil is well drained, normal soil, we can go for that is sandy loam soil, loamy towards moderate, light to moderate soil, we can go for 1 meter cube, 1 into 1 into 1. In the case of sandy soil, light soil, we can go for 0.6 meter cube. In the case of hard soil, we have to go for 1.2 meter. You can see that here, when you are making pit making, 1 meter depth we have to make. At the bottom of the pit, we can go for 1 kg of sodium chloride, so that actually it will lose the soil. And over that, to coming to the drought condition, whether you are having enough irrigation or not, that the initial time we can go for 2 layers of coconut husk. So that will be conserve the soil moisture. After putting 2 layers of husk, what we have to do? The top soil, while taking pit, we have to be very careful that the top soil should be separately taken. And after putting husk, we have to fill with the top soil. Then we have to take a baby pit for planting. And after that, like I said, coconut is like a baby. We have to be very take care for that initial time to avoid shading for sun scorching. In some areas, you can see that waterlogging area is there. If we are going waterlogging areas, that area, naturally your ceilings will be dry 1 or other day. In that area, it is better you can go for mount method. Then when we are coming about water management, there is no second thought that drip irrigation is the ideal. On any account, whether you are having irrigation water is abundant or not. Flood irrigation is not at all recommended. The drip irrigation is ideal one, and most ideal, it's a companion, we can say that, because why drip is ideal? It is directly, you can apply the water to root zone, and water saving, actually up to 33 to 50%, not only water, and because of better water use efficiency and what fertilizer use efficiency, we can save 50% of the fertilizer and weed control and efficiency. But the thing is, what we have to see that the most important that drip irrigation is the most important thing is that how you are implementing. It is more easy, but that we have to take care from the day one. We have to take the pits 1 meter away. We can go for subsurface. That means that 1 meter from the trunk, we have to make a small pit, 1 feet, 1 feet, 1 feet. That pit filled with coir pit or some organic material. There we have to go for 1 feet old use drip pipe or PVC pipe, so that your dripping point exactly touching 30 centimeter at the soil depth. You can see here, when you are planting correctly up to 30 centimeter, we won't see any depth. That means it is automatically indicating that we have to irrigate at 30 centimeter depth, where majority of the coconut roots are confined. But the major problem is that when you start drip irrigation, don't wait for till the soil is dry. When the soil moisture is 75% itself, because most of the farmers in the areas benefited by monsoon season, people will be waiting for 2 or more months after monsoon. No, actually, when the soil moisture is sufficient during post-rainy season itself, we have to start. Then after, depending upon the rainy days, you can stop, or if the rain is not there continuously 4 or 5 days, you can go for drip irrigation. Mulching is must, like cloth for human beings. And intercultivation, of course, the major thing is you can go for zero tillage, but they have to be very careful that you should not go for flowering too close. Always allow 60 centimeter leave from the trunk. And it is recommended plowing or even slash weeding. When you are going for organic or minimal tillage also we can go. But if you are going for plowing, it will summer plowing mean it will conserve soil moisture, And post-monsoon season means it will conserve soil moisture, control weeds, and most importantly, aeration. Then the most important point after water, nutrition. Nutrition has to be started from the day one planting. In the case of polybag seedlings and in the case of coconut, that field sown nursery seedlings, we have to wait for 3 months till the new roots are established. But the major point is that it is better to analyze the soil once in 3 years. It is a must. Based on that, your soil, what is the problem? Accordingly, apply nutrient. Then always go for integrated, organic and plus inorganic. And when you are going for acid soil, liming is must, or a dolomite we can go for. In the case of alkaline soil, you have to go for gypsum. That most important thing is that organic manure is to find a must place. And the question is that well decomposed organic manure, so that we have to decompose the organic manure. At least you give the time 3 to 5 months, otherwise you can say CN ratio should be less than 12:1. Then always avoid rainy days, and at the same time insufficient soil moisture also, we should not apply nutrients. Organic manure practice, because it's slowly available, so that organic manure can be applied once in a year, and there is no substitute for organics. Organic manures are equated like mother milk. There is no substitute, because organic manure improve physical, chemical and biological properties. Then coming to phosphorus, as per the CPCRA findings, once your soil is 20 ppm, you need not apply the phosphorus another 2 or 3 years. Once your soil is 10 ppm, you can go for 50% of phosphorus. Chemical fertilizer need based. In the case of rainfed condition, that is where it is only fully dependent on rain. You can go for 2 or 3 splits, depending upon either unimodal, means only 4 months monsoon is receiving, or 4 to 8 months, some of the areas near equatorial areas throughout the year. So that area we can go for 3 to 4 months. Only thing is, when you are applying fertilizer, chemical fertilizer, find that optimum moisture. So to avoid that, we can go for drip irrigation, means we can go as many as split possible, 7 to 10 split. So in the case of rainfed coconut, immediately after the receipt of monsoon, we can go for 1 kg lime or dolomite in the radius of 1.8 meter. In the basin area, we can apply, mix it. Then we have to wait for 15 days, 15 to 30 days. Over that, you have to apply chemical fertilizer based on soil data, then cover with the soil. Then second, towards the end of the rainy season, when you are having sufficient soil moisture, so that time we have to open a basin either manually or power tiller at a radius of 1.8 meter radius with a depth of 20 centimeter. You can see when you are planted correctly, you won't find any roots in the basin. So after opening, if you are not applied dolomite or lime in the beginning, now again we can go for lime or dolomite or gypsum depending upon your soil pH. Then we have to mix with the soil. Dolomite mechanism will be the added condition. Then over that, as a green manure, we can go for Claricidia. Then after that Claricidia, we have to apply chemical fertilizer based on the recommendation. Then we have to cover with the soil. Over that, we can go for biofertilizer, phosphorus and phosphobacterium and azosphaerlum we can apply. Then in the place of green manure,
Subramanian, you have 2 minutes left. Thank you.
Yeah, please. Poultry manure or goat manure, biogas slurry or kaya pith manure also we can apply 30 to 50 kg. And CPCRA has developed innovative technology. That means coconut itself providing an option. You need not go out anywhere else. The coconut leaves, for every year you can get 5 to 8 tons. That leaves can be recycled through vermicompost technology by utilizing useless earthworms within a period of 70 to 80 days. That can be recycled. So that can be you can go for vermicomposting tanks, or we can go for in the institute also. Then in place of that, we can go for basin management also. That in the immediately after the receipt of monsoon, the basin we can go for sowing of leguminous seeds and cover with that. When monsoon is ends, that time we have to again mix, and you can with chemical fertilizer we can do that. Then most importantly that in spite of all the things, some sort of inherent problem, if we come across some nutrient deficiency, we have to properly diagnose and correct the problem then itself. Don't wait for too late. So potassium, you can see the deficiency. Nitrogen, potassium is most important for copra and drought tolerant. Nitrogen for growth and yield, magnesium growth and yield, copper, and most importantly boron. You can see that the leaves are not splitting and nut splitting. The nut size is small. All the things are related to your boron and potash. That also we have to based on your soil. We can apply zinc also. Then the most important, because nowadays what is happening, the soil moisture is, water is resource are dwindling, decreasing day by day. So that our idea is that collect, conserve and utilize. Wherever plain and slopey area, we can go for mulching. So mulching also we need not go outside. Simply you can get coconut leaves, coconut husk and coir pith. Wherever slopey area, we can go for half moon punt with pineapple powder and contour trench. There also what we have to do, husk barrier. In addition, in the interspace where when you are going for monocropping, we can go for cover crops, both plain area and slopey area. Denja, cowpea, mimosa, depending upon the your soil condition. Then coastal sandy soil also same technology. The idea is that the same technology, even in the coastal sandy soil, we can go for intercropping. But the final point is that in the best practice, actually coconut is the ideal companion for all the crops. When you are going for coconut is monocrop, it is not utilizing the available soil water resource effectively, and most importantly that more than 20 million holdings are small holdings, so that we have to improve the productivity and income we have to go for. But coconut is a natural companion for cropping system, farming system. The reason is that it is single trunk and 25% of the area is only covered by the effective root zone covered by the coconut. And most importantly, agriculture, light is more important. Coconut, because of the leaf canopy structure, light is available under the canopy. But you have to see that according to the condition. On any account, you should not go for any intercrop in the basin area. And most importantly, you have to apply fertilizer and water for your intercrops also. And these are all the some of the coconut crops. Almost all the crops we can go for that according to the agroecological and market demand. We can go for coconut cocoa and high density multi-species, and most importantly, because today's topic is sustainable, coconut based integrated farming system, so that you can really integrate all the allied interspaces, so that the system is self-sustainable, and at the same time you can have higher employment generation also. Then pest management also, actually through good management practices, we can able to manage coconut rhinoceros beetle, all the red palm weevil, as you can see that cooking of beetle and leaf axe milling and meteorism using nylon fish net, all the things rhinoceros you can manage. Same way red palm weevil also we can manage, and it's already proved that the coconut area fit mite also it is very well we can manage, and the black-headed caterpillar biologically very well is we can control. Only thing is timely we have to manage. And recent past also that rugose spiraling whitefly, that is also we can go for farmer friendly and holiday approach, and to conservation biological control of encartia. Definitely we can overcome with good agriculture practices. We can manage like that. Similarly, disease management also. That finally harvesting, regular harvesting is must, and we have to go for 45 to 60 days, because unless if you are not harvesting regularly, the hygienic of the plant also affected, and you have to take due care when you are doing harvest. Then final but not last but not least, coconut is a smallholder crops, so farmer expects resource consent, so that we should go for group approach, facilitate farmers producing organic community approach to collect all the nuts and to promote value added and market, to help them for marketing, so that they can enhance market. That is tremendous. As Dr. Padukal already gave that now already more than 153 product now already it is available, so that coconut is giving a wide option. So to conclude my talk, adoption of a holistic approach by employing good agricultural practices would enable to bring best of coconut. Only through good agricultural practice would enable to bring best of coconut and at the same time sustain the coconut productivity. Thank you for your hearing. Thank you very much.
Thank you very much, Dr. Subramanian, for your presentation. The next speaker is, so far we've heard from the Philippines and India, two of the most important coconut producers globally. Now we're going to hear from Dr. Nayani Arachije, who's the principal entomologist at the Coconut Research Institute in Sri Lanka. And she's going to talk to us about integrated pest management to sustain coconut development. So without any further ado, I would like to hand over to Dr. Arachije. Thank you.
Thank you, Vincent, and hello, everyone. The topic that I'm going to discuss today is one of the most important aspects in sustainable coconut development. As you can see on the screen, it is about the integrated pest management to sustain coconut development. Coconut is an important crop, and especially in the Asian. Sorry.
Could we? I can't see your presentation yet. So perhaps you could start again and make sure that. Who is presenting this? Is it ICC or is it you directly?
Naini only. Naini, you can share your screen. It is not yet shared. Dr. Naini?
We seem to have lost Dr. Nayani.
I think some disconnection happened, I think. She is not visible now.
I wonder, perhaps you could send a mail to Dr. Oh no, look, she's reconnecting.
Yeah,
reconnecting. While Dr. Nayani is reconnecting, just to remind everybody that we can, if you type your questions into the chat, I'm making a note of them and we'll be addressing them in the discussion section. Okay, Dr. Arachije, could you share your screen, please, and recommence with your presentation?
Yeah.
Thank you very much. And whilst we're reconnecting, just to say that we're waiting for the fourth speaker, Dr. Jimmy Botella, who's not come online yet. So I'm hoping that if he's invisible, perhaps he can tell us that he's here. Otherwise, we'll be trying to get hold of him during this current presentation. Over to you, Dr. Arachije.
Okay, thanks. Vincent, is it okay now? Can you see my presentation?
Yes, we can. Thank you.
Okay, right. Thanks, Winston, and hello, everyone. As I said earlier, the topic that I'm going to discuss today is the most important aspects in sustainable coconut development. And as you can see on the screen, it is about the integrated pest management to sustain coconut development. As we all know, coconut is one of the important crops in the Asian and Pacific regions, as it plays an important role in the economy, society, and the culture in the countries where it is grown. And it is getting popular in other areas as well because its health benefits are well recognized now in the world. Currently, the global production surpasses 60 million metric tons, but the production could have been increased more through good agricultural practices because its production is greatly reduced due to many biotic and abiotic factors. Pests and diseases are among the main biotic factors that reduces the crop yield. So far, more than 700 pest species belonging to insects, mites, and mammals have been reported worldwide. But in some places, other animals such as weaver birds also cause severe damages to the coconut palm. Pest damages different plant parts of the palm. For example, pests such as rhinoceros beetle, red palm mite, black-headed caterpillar cause severe damages to the foliage, while red palm weevil damages the palm trunk, causing lethal damages to the palm. And if you take coconut mite and rats, they are the pests of fruits of coconut. Also, different pests cause economic damages when they feed on the palms at different stages. Therefore, the decision making on the IPM of your coconut plantation has to be taken very carefully, and it greatly depends on the type of pests and diseases of the plantation, whether it is a young plantation or an adult plantation. Otherwise, you may spend a lot of resources, but at the end, your return will not be reflecting what you invest on the pest management. The composition of the pests of coconut differs from country to country. One major pest in one country or in one region may be a minor pest in another place, or may not be a pest at all. And the pest that I have shown in this slide as major pest of coconut may not be pests in your country. You may get a totally different group of pests, but these are the most common pests in many coconut growing countries in the world now. As we all management tools in a sustainable manner, we'll be discussing about some of them in my next few slides. So we all know about the advantages, the importance, and the need for IPM in any crop, but why it is a need in coconut specifically? One reason is that it is a perennial crop, and therefore susceptible plant parts for a given pest are available throughout the year. So it may not be possible to keep on applying a single pest management tool throughout the year. And it could be very costly, and therefore integrated sustainable methods are really necessary. Moreover, it's a tall plant, and therefore insecticide application is always not feasible, economical, and effective. Also, the damages may not be visible to the farmer because of the tall nature until the pest population reaches an uncontrollable level. Therefore, avoidance of the pest reaching the economic threshold level through cultural and mechanical tools are mandatory. Most of the pests are in hidden habitats of the palm because it has a huge structure, and also sometimes only some instars are available on the palm. Therefore, controlling the pest using one tool is not practical. We may have to use one tool to control the adults, while another tool to control the immatures. Sometimes even low toxic methods are ineffective. The best example is the rhinoceros beetle guam type, which is not susceptible to any of the available nudibvirus strains that are available in the world now. So let's see what the different tools available for IPM in coconut are. Most of the coconut pest outbreaks can be avoided or prevented by practicing good agricultural practices. So once you start practicing good agricultural practices, your pest problems in your coconut palms become less to a certain extent. Through cultural practices, actually what we do is we adopt good agricultural practices. Most of the pests that, for example, certain examples, if I take some examples, most of the pests are bred within your coconut plantation, and by destroying the breeding grounds, you can prevent pest damages to a certain extent. For example, rhinoceros beetles and rodents, one important component in their IPM is to destroy the breeding grounds. But we have to make sure when we are destroying the breeding grounds, sometimes the dead beetles are breeding inside the dead palms. So those dead beetles will be the sources of nudibvirus, and therefore farmers should check the breeding media actually before discarding them. Selection of suitable lands and correct planting of coconut are also important in preventing some pests and diseases. For example, poorly drained soils will increase skipper butterfly and collar rot disease. And palms planted in hard pans are always under stress, therefore the pest can easily infest such palms. And shallow planting can increase the red palm weevil damage because the roots and the bole region are exposed in shallow layers, and the root proliferation is high, and they will attract the red palm weevil females. Soil moisture conservation is always beneficial because it reduces the moisture stress to the palm and thereby the buildup of pest populations. And correct application of fertilizers not only increases the palm vigor to fight against pests and diseases, but it also prevents the succulence of plant parts to pests and diseases due to some excessive use of certain nutrients. Mechanical methods are the tools that involve mechanical devices and barriers and the direct involvement of the man to prevent pest damages. Some examples are winkling, that is we extract rhinoceros beetle using metal hooks, and also we can cover the crown region to avoid the entry of rhinoceros beetle. You can also use fishing nets to trap the beetles emerging from the breeding grounds. And you can also cover the ball region for rodent management in young palms. Tree banding and baiting for rodent management, and electronic detectors developed for red palm weevil are some other examples in mechanical control. Biological control methods are among the most environmental friendly tools for pest management. Their action is slow, but the effects are long-lasting. You can see some of the examples of well-known biocontrol agents in coconut pest management in this slide, and we will see how some of them are used. One example is green muscarine fungus for rhinoceros beetle. The fungus is artificially infected to healthy larvae of rhinoceros beetle or to maize grits or rice grits, and incorporated into the breeding grounds. So the adult weevils visit in the breeding grounds and larvae get infected from them. So this is one of the excellent methods, but in Sri Lanka we have experienced that this method, when we use this method, it highly depends on the humidity in the environment, because if the pits or the breeding grounds are dried up, we cannot sustain the GMF fungus in the breeding grounds. Use of Oryctes rhinoceros nudibvirus is also another biological method for rhinoceros beetle control, and this is a very effective method. You can infect the beetles artificially by force feeding or by allowing them to swim in a virus solution and release them into the field so that they will transmit the disease to healthy beetles. This is an auto dissemination system of the virus. Use of parasitoids for black-headed caterpillar is another classic example. Here you can see two of them, Bracon brevicornis and Goniosus nephantidis, both parasitizing the larva of coconut black-headed caterpillar. In Sri Lanka, we have a predatory mite, Neoceros baraki. We have recommended it to manage the Azaria mite. And the entomopathogenic fungus Hirsutella thompsoni is recommended in India to manage the same mite. They have commercial formulations too. Now in this system, actually we cannot eradicate the pest population, because the pest is in a hidden habitats, and some of the biological control agents cannot reach their hidden habitats. So it's very tricky in identifying predatory mites and entomopathogenic fungi for coconut areophid mite. In Sri Lanka, what we expect from the biological control is that now, because of the coconut areophid mites, usually the nut size is reduced, and that is the main reason for the yield loss that is experienced by the coconut farmers. Therefore, by introducing the predatory mites into the infested palms, what we expect is to reduce the nut reduction, the size reduction of the nuts. Biological control of Brontispa longissima, which is commonly known as the coconut hispine beetle, using Tetrasticus brontispae, Acicodes hispinarum, and GMF fungus are another examples. You can see here the newly emerging fronds of the palm are pest-free after releasing the parasitoids into the field. And biological management of the diseases is also possible, mainly by the antagonistic microbes such as Pseudomonas fluorescens, Bacillus subtilis, and Trichoderma species. Host plant resistance is another tool, and this could be perhaps the safest and the most sustainable method in a crop which stays in the field for more than 50 years. By planting resistant coconut varieties at the beginning, the farmer can greatly reduce the post-establishment pest management cost. But developing a resistant or a tolerant cultivar takes very long time in coconut. These are some of the examples. In Sri Lanka, we have identified varieties like Sri Lanka yellow dwarf and Gonthambili and they show certain tolerance to the aceriamide. And India, they have a variety called mide. Again, in India, they have released at least 3 varieties, namely Kalparaksha, Kalpasri, and Kalpasankara, with root wheel disease tolerance. And in Sri Lanka, Sri Lankan green dwarf is mostly free from the Valigama coconut leaf wheel disease in the endemic area. And the same variety is known to be tolerant to the lethal yellowing in the African region and the other regions. Behavioral manipulation of pest is mainly done through the pheromone traps in pest management. And this tool is used not only to trap and kill the pest, but also as a population monitoring tool. These pheromones are artificially synthesized and used in traps. One example is rhinoceros beetle trap, which uses ethyl for methyl octanoid. And the other example, actually in Guam, it has been observed that UV light emitting diodes coupled with lure and pan traps equipped with horn and UV LED are more effective in trapping the beetles than the standard vein bucket trap. Another example is the trap that is used for red palm weevil, and pheromone use here is for ethyl 5-nonanol. These are some of the different types of red palm weevil traps in the world. When we use these traps, especially for rhinoceros beetle and red palm weevil, one important thing that we should keep in mind is that the traps should be installed well away from the young plantation, preferably in a non-coconut area or along the periphery of the plantation. Otherwise, we have observed that if the traps are installed close to the young plantation or within the young plantation, the damage could be high. Another important thing is that the use of pheromone traps are successful when a government-assisted farmer participatory approach is practiced. And it is even more effective if community-based approaches are taken where the pests are trapped from a large area at a time. Botanicals, mainly based on neem, that is azadirachtin, are widely used in pest management in India, but I think botanicals have drawn less attention compared to other methods in coconut pest management in other countries. Use of insecticide is perhaps the last resort as a pest management tool in IPM of coconut, and this is the most effective method, but it has serious unfavorable effects on the environment and the coconut products, because especially the lipophilic compounds in insecticide can get bind into the kernel. Therefore, insecticide should be judiciously used, perhaps as the last resort. But it is an important component in the lethal pest management, such as red palm weevil, and as a prophylactic method. These are some of the examples of insecticides that are recommended for certain pests in coconut, but you have to make sure that you use safe methods such as trunk injection or root feeding when you use highly toxic insecticides such as monocrotophos against different coconut pests. Vigilance at seaports and airports are important for avoiding the hitchhiking pest. And it is always advisable to follow FAO IBP
2 minutes left,
guidelines.
Dr. RHEJ, 2 minutes left. Thank you.
Thank you. Okay, thank you, Susan. Thank you. It is always advisable to follow FAO IBPGR guidelines for safe movement of coconut germplasm. This is really useful and applicable for rhinoceros beetle, Guam type, coconut hispine beetle, coconut fall scale, and red palm mite nowadays. And the crop habitat manipulation and diversification is done to create volatile confusion and the disorientation of the pests through the integration of other non-host crops or the crops that are favorable for the natural enemies in the system. This is in a way a type of agroforestry system which will always show some benefits to the major crop, that is coconut. And having said that, I would like to conclude my presentation, and thank you very much.
GJ, thank you very much for a very full and interesting presentation, and likewise Dr. Subramanian before that. The next subject that we're going to present is from Professor Jimmy Botella, who's the Professor of Plant Biotechnology at the University of Queensland in Brisbane. And his...
He's there.
I beg your pardon?
He's there. Jimmy is joined.
Oh, okay, fine. So welcome, Dr. Botella. and we're delighted that you're able to join us today to talk about the potential of satellite-based surveillance methods for lethal yellowing disease control, and also, more importantly, to discuss the way that we can detect the disease. I know that you've produced this really fabulous diagnostic tool, so over to you, and thank you very much.
Thank you very much, Vincent. Can you hear me? Is that okay? Can you, everyone hear me? Yes?
Have you got the PowerPoint presentation, and can you share your...
Yes, I do. I shall put it now. Okay. Is that okay? Can everybody see me?
Yes, we can see you fine. It's on full screen. Thank you.
All right. Okay. First of all, I want to thank Gerfina and the organizers of this workshop for giving me the opportunity to talk in here. I've been asked to talk a little bit about the present and the future of disease monitoring in coconuts, especially the lethal yellowing diseases in coconut. We have been working on that on a field-ready disease resistant, disease diagnostics. Now we would like to take the next step, that is having an automatic monitoring of the disease. All right, I'm going to talk about the coconut syndrome, the Borgia coconut syndrome, also known as lethal yellowing. This is a phytoplasma disease that is present pretty much everywhere in the world now. It started in the Americas and the Caribbean, and now there are reports of it being in Africa, in Asia, and in Oceania. This is the kind of disease that not only affects coconuts, but also other palms. From our results in PNG, we can tell that it's also present in banana plants. So that's what the disease is. It's a very devastating disease. When it comes and it infects a field, the palms will die in pretty much 4 to 4 months, 3 to 4 months, and they'll be dead. All right. So it's important to have a way to eradicate the disease. In order to do that, monitoring is everything. Now, monitoring has 2 components. One is surveillance, and the other one is confirmation. All right, so the surveillance is about how to identify trees that look suspicious of having the disease, trees that might be sick, although we don't have 100% proof. And then the confirmation is how can we confirm or deny whether that tree is infected with the phytoplasma disease. Let's talk about surveillance. What exactly are we looking for? Well, it's pretty obvious. We're looking for sick trees. And when we go to PNG with the people from the Coconut Corporation, KKK, they are fantastic. They look at a tree and they say, yeah, that is a sick tree. Then we do the diagnostics and it's true, all right? And how do we look for them? We look from below. We don't go on top of the trees. And we look with your eyes. You're going to say, yeah, that's obvious, Jimmy. How else can we look for them? Well, I tell you, there are alternatives, all right? One alternative is to look from above. And today, looking from above is quite possible. And the other alternative is to use a different set of eyes. What do I mean by a different set of eyes? Well, look, our eyes are very poor. Our eyes can detect a very narrow spectrum of the entire wave spectrum. So let's talk first about above. How can we look from above? One way we can do is use satellites. Some time ago, it was pretty much impossible to dream about doing this, but today, with the high-resolution satellites, you can get really detailed pictures of your fields pretty much anywhere, almost anywhere in the world. Low-resolution satellites give you 60 meters per pixel, but it's obviously not enough. Medium resolution gives between 10 and 30 meters per pixel on a picture. And high resolution, and very high resolution, can give you an amazing 30 centimeters per pixel. That can even be combined with enhancing, software to give you even a more detailed satellite picture. That was, some time ago, that was unthinkable. Today, it's possible. And the other way we can do that is with drones. And everybody's talking about drones. Yeah, we've been using drones for our agricultural research at UQ for a long time. And the best part about drones is that, as you see here, you can attach a number of different kinds of cameras. What kind of cameras? Well, that is the second part. The second part is what eyes do we use? Your eyes are good. But if you look at the visible spectrum, that is what your eye can actually see, the visible spectrum goes, from the blue to the red. It's pretty small. When you look at the entire spectrum that you see here, it only takes this little part of the spectrum, where you can see you have also things like gamma rays, X-rays, ultraviolet, infrared. You have the radar. You have a lot of things that you're not using when you use your eyes. So you can actually have different set of eyes that will actually see different things, like the near infrared fluorescence, the near infrared or the fluorescence. You can also use eyes to see thermal images, something that you couldn't by yourself, but today the technology allows to do that. So that is really important. And what exactly is it that we are looking at? We're looking for the symptoms, all right? What kind of symptoms? The first symptom that you see in BCS, they start dropping their fruits. So it's one thing that you can start looking for. Then the trees show a bit of a yellow canopy at the beginning, and they start going more and more yellow. Of course, because it's a phytoplasma disease, the phytoplasma lives in the phloem, so it restricts phloem movements. Now, restricting phloem movements actually means that your plant will be stressed. When plants are stressed, one of the things they do is they lower photosynthesis. And that is just not for this specific disease, it's for any kind of stress in plants. One of the responses is photosynthesis will go down, the efficiency of photosynthesis. So what in surveillance, what is the essential requisite? What is the one thing that we need to look for? Well, what we need to find is a spectral signature for the disease trees. That essentially means, how can I interpret my eyes or the data that I take in my pictures? Call it infrared, near infrared, fluorescence, thermal. How can we recognize, is there a signature? Do the disease trees actually look any different from healthy trees? Now, if we can do that, there are a number of other questions. For example, how early can we find our trees? How can early in the disease can we find the trees? How does it change the spectral signature? How does it change as the disease progresses? Is it at the beginning, you have one kind of signature, in the middle you have a different kind of signature? And of course, can we use artificial intelligence and machine learning to recognize your symptoms? Let's look at surveillance. And surveillance have two elements. One is image acquisition, is how do you take your image and what kind of image do you take? And the second one, very important one, because we're talking about digital technologies today. Every kind of image you get will be digital, so it will be in zeros and ones. So essentially what you need to do is to analyze your image. Image acquisition, how can you do that? Well, if you use drones, drones are fantastic for high resolution, but they're limited in the amount of, in the size of the surveillance that you can do. It's for relatively small scale. And when they say small, it's not that small at all. But I'm saying you cannot use drones to do an entire province. But you can use drones to use really, big surfaces, all right, and big cultures. It's very fast and it's cheap. Drones are not that cheap, the good ones, but once you have it, you just use it forever. Satellites are good for large regional and national programs. We're talking about larger scale, but of course you're going to get lower resolution than drones. And it could be more expensive because satellites, I mean, the good ones, you have to pay for it. So you need to pay to download your images. Of course, satellites have a number of other problems. For example, the cloud cover. There are places, you know, and there are days where you cannot take well, you can take some satellite pictures, but very specific ones. Because if you got cloud cover, it's gonna distort everything, including your visible, including your thermal, including pretty much everything. But once you have your image, as I said, it will be a digital image. It's not only what you see, it's how do you analyze it. And I can give you a good example. This is something that we use quite a lot in when we do image analysis of our fields in agriculture. It's called NDVI, or Normalized Difference Vegetation Index. Look, it's just a formula. It's a formula. What you do, if you measure the reflectance, you know, you have a camera in the near infrared and you have another camera in the visible, mostly the red. And then for every pixel, you measure the amount of near infrared, you measure the amount of red, and you do this formula, and you have a number for every pixel. Now let's put it here. When talking about plants, this is really good to look at the health of plants. This is a normal plant that is healthy, and what it does, it reflects the red, it reflects the infrared, and you do your calculations, and you get around a 0.8, 0.9 in your NDVI value. For a stressed plant, a plant that is turning yellow, that is stressed, you're going to have more or less the same infrared, but a lot more red. So you have this value, 0.1. So you can actually see that a 0.8 gives you a more healthy plant, a 0.1 gives you an unhealthy plant. You do that for every pixel, and you'll see that depending your healthy plant, your stressed plant, and your completely dead plant will give you different signatures. Look at this field. If you look at the field, pretty much it all look okay. Whether it's good or it's bad, they all look the same. When you do an NDVI, you get a much different picture. What you see here in NDVI is you have areas that are a lot more stressed than others. And normally, with your eyes, you will never be able to see that. Now, that is a typical satellite images, and you can do that, you know. And of course, you can use machine learning, and this is not our work. This is a beautiful work from CIAT that's been just published. This is the kind of things that you do. You start calculating values and going around and around in a way that the machine will learn. And what does it learn? Well, I'll tell you what it learns. This is a typical signatures of banana plants with different diseases. This is a healthy banana plant, and these are two different diseases. If you look at these NDVI images, you will see that they have different spectral signatures. You might not be able with your eyes to say this is sick and this is healthy, but if you put it on a machine, the machine can learn, and the machine is much better than you. In this picture, you can see where they have identified a number of banana trees, and those that are in green are because they're sick. In this other picture, they're also identifying banana trees with a different sickness. This is it. This is one sickness. This is a different sickness. The machine will get your images, will analyze them, will learn, and will tell you what is good and what is bad. So, what could we do for lethal yellowing? First, we need to locate trees at different stages of disease. Then we need to collect spectral data or images with drones and with satellites. And then we need to start doing mathematical analysis of the data. This is really all mathematically done. It's way more complicated and technical than anything else that we've used. But it's being done already, so it can be done. Then we use machine learning, artificial intelligence, and then we can create surveillance methods for local systems and surveillance methods for wide area systems with satellites. That is great. This is an example. This is the Madang Stewart Research Station, where I've worked quite a lot. This is this different magnifying things from the World View satellite. This is the station here. This is an NDVI image of the trees in front of the station. This is a bit more magnified. From the satellite, you can actually see every single tree in here. When you go to an NDVI here, you're not going to be able to see every tree, but the machines can see it. The machines can learn. And this is even more. This is a 50 by 50 square where you can actually almost see almost every single front in the trees. These are the images. Again, to your eye, doesn't mean anything. To a machine, it can mean a lot. And finally, you need to do the confirmation. Once you have suspicious trees, you need to send the team to test for the disease. We already have a field-ready systems developed for BCS in PNG, and we were about to deploy them when COVID came and we have to cancel everything. We're waiting to see when can we travel again. I can show you how it works. It's in this video. The first thing that you do is once you get your samples, in this video we are using a tube with a leaf. For BCS, you use sawdust, all right? So essentially, instead of doing that, you put sawdust in there. We use the lid of the tube to know how much sawdust do we need to put in. We mix it up very well with the buffer, and then we purify the DNA contained in those samples. That is as simple as this. You put the stick in there, you wash it, and you put it in your reaction. This is your reaction over here. That's the first part of it. So that's how you take a sample of a tree. You put it in your tube. And now, how do you analyze that? We have created what we call the diagnostic droid. We've put it in a coffee mug because it's very strong. You just load your tubes in it. You can see here that it's plugged into the wall, but it can also plug into a car. It connects with your phone. We have created an app. Essentially, this is the things inside. So you got a Bluetooth, connect with your phone. You put your tubes. You choose what kind of method do you want to use for detection. And then you can see all your samples. If you look at the bottom, you can see it's reading the temperature as it goes, 62.92. And when it's ready, it tells you, you can just push a start to start it. So all you need to do is press a start on your phone. And this starts working. And as they start working, it starts collecting data and it interprets it automatically. It will tell you it is positive or it's negative. You don't need to interpret anything. That's the way it is now. This is us in the field. This is what we go to a tree. We drill a hole in here to get a bit of sawdust. This is my lab in the back of a ute. And this is the machine plugged to the car. And when it's plugged to the car, all you need to do is wait, and it will give you the results. Thank you very much. That was all for my talk. I'll stop my sharing.
Vincent?
I beg your pardon, I'd muted myself. So I would like to just repeat to Jimmy, thank you very much for that fascinating glimpse of remote sensing and the molecular diagnosis of phytoplasmas. As you can see, everybody, the industry now has some tools which are practical and relatively cheap to assist in diagnosing various different pathogens. So now there are about, I've been keeping a tally of all the questions that have been coming in on the chat, and we have about 14 different questions. So I'm just going to go through them from the beginning to the end. And by that time, we haven't had any questions about lethal yellowing disease diagnosis yet, but we'll come to that later on in the discussion. The first question comes from Christopher Fernando, saying continuously we apply fertilizer to their coconut plantation, but then his nuts are small and decreasing in weight. He wants to know the reason and remedies that can overcome the problem. I think this seemed like a very general question. Perhaps Pons, you'd like to just comment briefly, because it seems like a big issue.
Can you repeat the question, please?
Yes, basically they apply fertilizer to their coconuts, but the nuts are still smaller than they should be, and their weight is decreasing from one season to the next. So he wants to know if you can diagnose the reason why this is happening.
There should be a first soil analysis if you feel that nutrition is a problem. Second, based on the presentations, any indication that there is a disease. Those two major components. Of course, it might be dry, and therefore it might need some moisture. So those might be the areas where you could look at.
Yes, I think, Christopher, we can't really go deeply into analysing our situation in this webinar. We can perhaps talk about it if you want to get in touch with us on an individual basis. You also mentioned what was expected yield increases from drip irrigation and fertigation. Pons, again, would you like to address that quickly?
Yes, using fertigation and other input systems, some countries are reaching 300 fruits per tree per year. And in fact, the best plantations of South America are reaching 400 fruits per tree per year. India is an example of a country that uses fertigation very efficiently in farmers' fields, and they're getting higher yields than other countries. Of course, we have to take into consideration that some of their varieties have small nuts. Smaller nuts usually are more in terms of number. So indeed, if you use the hybrids and you use the modern innovative technologies like fertigation, like increasing the cation exchange capacity through mycorrhiza fungus, you could achieve 3 to up to 5-fold increase in yield. And some countries like Mexico and Brazil are already demonstrating that that can be achieved.
Thanks very much, Dr. Pons. Rather than looking into the chat now, I'm going to go through each of the questions, and if we have any more time, we can take further questions. So the third question comes from Gali Batara Muda, and they're asking, I think this is probably a question for Dr. Subramanian. Is there an available model for integrated coconut plantation implementing good agricultural practices? If so, which country might be able to provide a good model for good agricultural practice? Dr. Subramanian and then Pons, perhaps.
That question
you might need to, yeah.
Am I audible? Yeah. So the integrating what all the technology discussed, definitely that can be applicable to all other countries also, because almost even you can see that weather-wise also this technology will be applicable. And regarding one specific question, flood irrigation, that also I can answer. The flood irrigation, it will invariably affect aeration. So when aeration affect, naturally your health of the farm is affected. The third one is when flooding, continuous flooding, what it is happening, it leads to leaching of nutrients, because your potash and nitrogen is highly mobile, and even boron also. So, and as I already told, and majority of the coconut roots are confined to 1 meter depth vertically. So naturally, continuous flooding, sometimes it's leaching, then it will affect your nutrient pattern also. So and most importantly, that now water is a gregarious commodity. Each and every day it is dwindling. So that on any account, flooding is not recommended. Then in addition that, especially in India, we are seeing that some diseases, especially wherever you can see that Canaderma disease, wherever flooding is adopted, naturally it will aid for spreading your Canaderma disease, and it will be a predisposal factor for Canaderma. So for that, so on any account, flooding is not at all recommended. And another thing is that
I think,
nutrient.
Sorry if I can just interrupt you a moment, Dr. Subramanian. I think the question is there a model available for people for good agricultural practice? Is there a kind of reference model for good agricultural practice?
So I'm not getting what model?
The question is there a model of good agricultural practice that producers can go to?
Model available to see which this good agriculture practices model where it is available for the see to the other people. They wanted to see how the good agriculture practices model is applied in the field.
Maybe Pons can help?
Yes, that I think as.
Would you like me to input, Vincent?
Yes, please. Just a couple of sentences about where people can go to look for a good model of good agricultural practice.
Actually, the full agricultural practice package is difficult to find in any one country. Components are available, and in fact, the objective should be to put them together and pilot and test in farmers' fields. The nearest I could see is the coconut farmers of India. I wish all coconut farmers can do the same. They take care of the coconut like a baby. Even just for agronomic practices, this is already excellent. Of course, there are demonstrations in various countries at the research station on good agronomic practices, but these are at the research level, and usually the output of a research trial is usually 2 times what you see in the field. It's 50%, assuming a good extension system. If you have an excellent extension system, you might get 75% of what you get in the farmer's field. But the best illustration of good agriculture practice actually at the farmer's level is India.
Thank you. I think what we need to do as a community in terms of the ICT, NAM and others is to get together and produce then the latest synthesis of extension information. I'm going to go on to the next question in the interest of time, and it comes from Johanifa Ismail, who was asking about bioinoculants. What are they? And in fact, Murali Gopal has already answered the question, saying that bioinoculants are microbial biofertilizer. I think this person comes from CPCRI in India. They've developed a plant growth promoting rhizobacteria-based biofertilizer for coconut seedlings, branded Kera ProBio, and containing Bacillus megaterium bacteria. Application of this biofertilizer to coconut improves growth and health of the seedlings. And they've also developed something called Kiram, which is arbuscular mycorrhiza containing bioinoculants. I think, again, perhaps, Pons, just a couple of words on bioinoculants from you.
Yeah, the most dramatic that we have seen is the application of mycorrhiza. And in the Philippines, they have packaged together 12 braces of mycorrhiza in one concoction. Mycorrhiza are fungus organisms that increases the cation exchange capacity of plants to absorb the nutrients from the soil. A lot of residual nutrients are already in the soil, but they are not in available form. And the mycorrhiza fungus usually increases the absorption.
Okay, thanks.
There are other countries that have similar formulation, and I think it is in the right direction because it's organic, and sometimes it costs very little. For the mycorrhiza, 12 racer mycorrhiza consumption, all you need to do is apply 1 tablespoon per tree, and that's sufficient. It will multiply by the millions, and you apply it only once in your life.
Thanks very much. Okay, we have some more questions coming in on the chat, but I'll carry on with this sequence, and we should have time to get to the end of the questions. The next question comes from Michael Adonis, Sudaria. Does seed nut orientation have negative effects on coconut fruit quality and yield? Is there any significance in this practice prior to field transplanting? Maybe Dr. Subramanian, you can answer that question about seed nut orientation, and please keep it brief.
I don't think see any difference between horizontal and vertical planting. It won't relate to any difference in yield and orientation. But when we are going for polyvac seedlings, we can go for vertical. And field sow nursery, when we are going for horizontal planting, maybe the nut CP is not having sufficient water, that can overcome. So that way advantage is horizontal. When if we are not assured that whether that water is there or not, or drought condition, in that condition we can go for horizontal. Otherwise, yield and quality wise there won't be any difference. I think I may clarify the doubt. I think.
Could I just clarify that you're saying that if you orientate the seeds vertically, it can avoid the issue. It's better for water access. Is that correct?
Yeah, that vertical, if you are going for, especially for polyvac seedlings, there won't be any easy transplanting, it will be there. That is the advantage. Vertical.
Okay, thank you. The next question, Pons, have you anything to add to that before I move to the next question?
No, really, as long as it has plenty of sunlight, because that's the major requirement of any plant, and in the seed bed, if you have plenty of sunlight, I think that should be enough to especially if grown in polybags. Usually seedlings grown in polybags give the best result because you shorten the time to bearing age, and you normally can take care of it very well, and therefore sometimes and oftentimes it produces more sturdy seedlings, more healthy seedlings.
Thanks very much. And then the next question, I know that we haven't been referring to our other two panelists yet, but these questions are in order of the presentations, so we'll be coming to you in a moment. The next question from an anonymous person is, why is flood irrigation not recommended? I think we've already
explained it, yeah.
done that, but perhaps Dr. Subramanian, you could just answer that question very briefly, please. Why is flood irrigation not recommended?
Flood irrigation is not recommended. Point number one, wastage of water. Second one, it is affect the soil aeration. Then third one, it will spread the disease. Then it will affect the nutrient uptake. So all these, then most importantly, the wastage of water. So all these point on any account, you should not go for flood irrigation.
Okay. The next one is probably for Dr. Arachije from Surya Mehdi. Regarding the coconut flowering stage, what are the major pests and diseases?
I'm sorry, can you repeat the question, sir?
Yes, regarding the coconut flowering stage, I think what they mean is when coconuts are flowering, for the inflorescence, what are the major pests and diseases during flowering, coconut flowering?
Okay. Some of the major pests in coconut at the bearing stage are the rhinoceros beetle. It affects throughout the life cycle of the coconut palm, and then during the younger stages, like from 3 to 15 years of age, the coconut is highly damaged by the coconut red palm weevil. And then at the bearing stage, coconut mite, coconut azaria mite, and also the rodents are very serious pests. And as I said in my presentation, during different stages of the crop, different pests are damaged, and at different stages, they may cause in different level of damages. For example, as I said, usually the red palm weevil is not a serious pest when the palms are beyond 15 years of age. So at the bearing stage, mainly the rhinoceros beetle, the coconut azaria beetle, azaria mite, and the red palm weevil, the coconut red palm mite, and rodents, and brontispa beetle. All of them can be major pests depending on the area.
I think she was referring particularly to the how the pests adversely affect the inflorescences.
Oh. For inflorescences, actually, the number one pest is the rodents, because they damage the coconut flowers. So number one pest is the rodents, and there may be some mites that could attack the inflorescences, but some are actually beneficial because they are pollinators. Mainly, I would say it would be the rodents that could damage the coconut inflorescences.
And I know you probably covered this in your talk, but what's the most effective and practical way for rodent control?
Of the inflorescence pests?
For rodents, what's the most practical way of controlling rodents like rats?
Okay. Now, mostly it is it's baiting, and then as I said, tree banding. Of course, you can practice tree banding if you have planted the coconut in a proper spacing. Otherwise, the crowns will be touching each other, so that even though you establish tree banding, the rats would be the rodents would be transferring from one palm to the other. And then you can use very toxic chemicals for baiting them, and for actually when they are at the seedling stage, you can cover them using iron nets, or you can use the tiles, clay tiles to cover the base of the seedling. So those are the most practical and applicable ways of managing rodents in coconut.
Thank you very much. And another question for you from Dr. Chandrika Mohan. Any whitefly species associated with coconut foliage? This is particularly in Sri Lanka, she's asking.
Okay, yes, the last year actually, towards the end of the last year and at the beginning of this year, we have experienced severe whitefly damages in the wet zone of Sri Lanka, mainly in the wet zone of Sri Lanka. So far, we have seen at least 3 species. One looks like Alerodicus destructor, and we found very few samples which are similar to the rugose whitefly, but we still have to confirm them taxonomically. And there was another species which was not very close to any of these the species that I have mentioned. One thing I should say is, although in our surveys, we did very limited surveys because we had very limited time after, because soon after this was reported, we got COVID problem, and then we had to close down certain areas. So what we have observed is that for some reason, after, let's say, after March or April month of this year, the whitefly population went down, and at the moment they are not causing very severe damages in coconut, but at the beginning of the year we could see a lot of damages, especially in the wet zone of the country. And actually we have a separate project for that now in our research agenda at the Coconut Research Institute.
Thank you very much. I'm going to try and get through to the end of the questions. We still have about 6 or 7, and it's we've only 6 or 7 minutes, so I'll do my best. The next one is actually a compound of 4 or 5 questions from Hengki Novayanto in Indonesia. And first of all, to Pons, this is just a suggestion that we can add another item for training to coconut farmers on marketing. The second one to Subramanian, and if you can keep this briefly, Dr. Subramanian mentions analysing the soil once every 3 years. What do you think about the leaf number 14 analysis, the 14th leaf analysis? Dr. Subramanian, can you quickly say something about that, please?
It is leaf analysis you want to say?
Yes, leaf analysis, the 14th,
yeah,
number 14.
Actually,
number 14.
Yeah, number 14th leaf from the top. Actually, every tree will be having, that healthy palm will be having 30 leaves. So naturally, 14th leaf we have to collect so that we can see the nitrogen, phosphorus and potash. In the case of boron, still we can go for younger leaf. But boron and other things, other symptom also easily visible, that unopening of leaf and button shedding. So from that we can easily do that. In addition, we can go for soil test also.
Fine. Yes, so you think it's a good standard practice to analyse leaf 14 in conjunction with soil tests, yes?
Yes, yeah.
Okay. And
so
then
it is always better, especially.
Yeah, carry on.
So,
carry on. I think you're breaking up a little bit, Dr. Subramanian. So I'll go on to Henki's next question for Dr. Arachije. Indonesia has a big problem with orosites, and particularly in coconut palms in Java. Most of their coconut palms near to the houses, and they raise livestock as well in the back in the home gardens. Do you have any suggestions to make maximum control to the orosites in that domestic situation, Dr. Arachije?
Is it rhinoceros beetle, Vincent? Is he referring to
Yes, I
rhinoceros?
suppose so. He said orosites, but I think that's, yeah.
Okay, yeah. For rhinoceros beetle, as I said, actually we have to go for integrated approach, and I guess he is referring to the integrated management in backyards. So what I would say is that when I go through the literature on rhinoceros beetle management, is that we usually should have a kind of an integrated approach, and also we should have a kind of an community approach. Even though the pest is in your backyard, the pest problem is in your backyard, and your breeding sites are in your backyard. Just by eradicating the breeding sites in your backyard, you cannot get rid of the pest population, because pest problems, because usually the beetles can travel a lot, and even if you control them in your backyard, you will get migratory populations from other areas. So my suggestion is that it has to be an integrated approach, and it has to be a kind of a community-based approach. And it will be more successful if you go for a government-assisted, coordinated approach, because we have seen even in small plantations, like what we see in our country, we get small plantations. The most of the plantations are managed by the smallholders. So what we do there is we have recommendations for different pests, but for rhinoceros beetle and let's say red palm weevil. So what the government does is, through the Coconut Cultivation Board, which is the extension arm of the country, they conduct large-scale trapping programs. What they do is they install pheromone traps. And also they conduct all the integrated, they use all the integrated tools at the same time in a large area. Let's say in one, they will establish pheromone traps in one area, and they usually cover about let's say about 25 hectares or 50 hectares at a time. So likewise, even if the plantations are small, even the breeding grounds are in your backyard, there is no point of controlling individually. You have to go for community-based approach, and we have very good examples. We have seen that the damages are coming down when you apply all the IPM package, IPM tools in a kind of a community manner. So the kind of mass scale trapping. That is my suggestion. Even if they are very small gardens, I think the government should assist the farmers by organizing large scale mass trapping programs.
Yes, I'm looking at the other. There's still many more questions, and we haven't even got to Jimmy's presentation. I think probably because we want to stick to time, what I'm going to suggest is that we've got a record of those typed questions, and we will provide the answers afterwards. And if anybody else has any more questions, you can send them to us, and we'll make sure that the answers are provided. For now, because we've got very little time to go, before I hand over to His Excellency Ambassador Dr. Novintoro, who's the Acting Director for the Non-Aligned Movement for the Centre for South-South Technical Cooperation, I'd just like to thank the 4 speakers for their excellent presentations, from Dr. Pons Vattugal, from Dr. Subramanian. In fact, we learned from those two that there are over 153 different products now available from coconut farms. From Dr. Arachije in Sri Lanka, who mentioned that there are 750 different pest species attacking palms at the moment. And finally, Professor Jimmy Botella, for his very illuminating presentation on remote detection, and the hopefulness of his presentation on the practicality of the technology. So now I would like to hand over to Ambassador Dr. Novintoro for the closing remarks. Thank you.
Thank you, Vincent. Let me begin by thanking the International Coconut Community, ICC, for its excellent support for this online training program on good agriculture practices, the planting program, and integrated pest management to sustain coconut. Thank you, Dr. Delfina Lau, for your kind facilitation. I would also like to thank Intern Congren Coordinator, Mr. Vincent Bernard Johnson, Ms. Mridula, and Mr. Alit Firmansyah for their hard work. I express my gratitude to the numerous extension officers, researchers, and coconut producers from more than 18 countries for their participation in the last 3 hours. I'm very grateful to all the resources persons who have given the time to address at this particular training. I'm glad to have participation from all of you in this training. When I took on the role of acting director of the Non-Aligned Movement Center for South-South Technical Cooperation, NAM Center, I realized that we had to resolve the problems faced by the developing nation in coconut industry, among others, low productivity and development in order to meet global demand. I think we start to do that. But we need a huge transformation that will turn it into technical cooperations, which is enabling many countries and millions of agriculture farmers to increase production and increase sustainability. The NAM Center cannot do it all by itself. Therefore, as I speak before you, I'm pleased to see a true form and sense of technical cooperation today. It is all-inclusive, collective solidarity. I have seen something I never saw before this event. There are hundreds of people from more than 18 countries being present. That is fantastic news. Finally, we are transmitting the message to all agriculture-related countries. I have seen researchers from Australia, India, the Philippines, and Sri Lanka leading the development of solutions to unlock coconut productivity in developing countries. I saw our women assembly behind the event, not only from academics, but also non-profit women's empowerment activities. You can also sense my enthusiasm as I know that we have set out to increase the sustainable production of coconut. Let me reflect a little about the concrete act come out of this forum. First, we accept that innovative technologies, technology transfer, and capacity building must be integrated. Second, we decide to follow a holistic approach by using good agriculture practices that would sustain coconut productivity. Thirdly, we agreed to further investigate, including selection and testing of additional biocontrol agents, the impact on pest control, and the role of coconut volatiles as vectors of pest diseases. Four, we have agreed to optimize the satellite-based surveillance technologies to detect pathogens in coconut tree and its future technical application in developing countries. We have an MOU with the ICC to establish training, technology transfer and workshop, and research and development cooperation for all these activities. NAM Center also agreed that these platforms could lead to investment in resources, science, and technology for pest management. Better management must be taken of integration between farm family and farm system, assessing resources, needs and problems for farm families, and continuing on farm and farmer R&D, testing consultancy with researchers. We should note that provided agriculture models are appropriate for local climate and adapted to the coconut farmers' resources. We all know that the unsustainable development of coconut is not something that we can become used to. We want to get out of it. The coconut producing countries must take the moment and take advantage of it. I trust that researchers and extension officers will take the lead with intergovernmental organizations as well, fulfill our dream of sustainable coconut production. Optimism can no longer be delayed. Now is the time to act. When you leave this platform, you have to lively dreams of farmers on your shoulders. The farmer's dream is not going to be ruined. We join this platform as individuals now. We are moving towards tangible steps we have formed together, united and deeply committed. We will work together to help farmers harvest the natural resources of their beautiful countries. Thank you very much.
Thank you very much, Thank you very much, Your Excellency. Before I wrap up the meeting, there is one fairly important question that I missed, and I would like to address if Professor Botella is still there. Have you any idea of the cost of your diagnostic system for our listeners? Thank you. Just quickly, Jimmy.
Yes, very quickly. Look, the cost can be anything between $4,000 and $8,000, depending on what kind of technology do you want to have in your drones. Now, the analysis need to be optimized. Normally, most of the software is relatively free, but you need to optimize it before you can use it.
Thank you very much. Well, I think without further ado, I'm sorry that we've run out of time. I have made I pasted all of the questions into my own notes so that we will be addressing those questions that we didn't have time to answer. Once again, thanks to ICC and thanks to NAM CSSTC.
Vincent, we can have a group photo in the last.
Oh yes, I do beg your pardon. Before everybody goes, can we now turn on our videos? This is everybody who's still listening. Because we want to be able to take a group photograph. So I need to stop sharing my screen. Just a moment. Right. We still have 121 participants and 10 panelists. So, Alit, if you'd like to take charge of that, I guess. Are you doing the photograph?
Okay. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, done. Thank you.
Thank you.
Thank you very much. And enjoy the rest of your evening, everybody. Perhaps Jelfina Mridula, we can come back and have a brief discussion online, or can you stay online now? And we'll just quickly have a debriefing, if you have time.
Thank you so much.
Okay. Yes,
Thank you all.
everybody.
Thank you.
Thank you all.
Jimmy, Dr. Subramanian, Dr. Naini, Dr. Pons,
Professor Jimmy.
Ambassador, Miss
And
Nikki.
don't forget to fill out your online evaluation, please, and then get your attendance certificate. We will, as I said, be sharing the information and I will summarize the questions and answers.
Okay.
Thank you very much to the organizers. Excellent job.
Bye-bye.
Thank you.
Bye.
Bye-bye.